Okay. Today we are going to discuss regarding code quality. As you can see here, our topic clearly mentioning mastering code quality. So what exactly a code quality mean? You always remember when we write any programming language, we need to keep certain things in a mind. Okay. The first thing, how well structured your code is. Second, how well written it is. Simply nothing but code quality. Okay. So I'll give simple example. Let us say I'm writing if x greater than 30. When I write x greater than 30, you'll understand here we are passing a variable called x and we are checking whether the given value for x is greater than 30 or not, right? But what this x mean? That is a question mark. So if you are writing this logic is for the marks comparison, then we need to declare variables as a mark. Okay. So this thing is nothing but what? Readability. Okay. So when we write a code, okay, the code should be readable and understandable and maintainable. And this is called what? Code quality. Okay. So why we need to focus so much into the code quality? Why we need it? Okay. That thing we are going to discuss and we are going to travel through this lecture. Okay. So first thing, when I say it is a code quality, you need to keep several reasons, okay, in a mind. First one, readability. Just now we discussed. Second, maintainability. Third, efficiency. Fourth, reliability. Fifth, security. Okay. These five reasons, due to these five reasons, okay, we need to maintain a code quality. Now, what is readability? You might be having a doubt. What is this readability when it comes into the picture? Okay, so for this, simply I try to write one method called calculate. Okay, so public void calculate grade. You're passing score, okay, into the method. Okay. So if you see here, in this case, if score rather than or equal to some 90 or 80, it's up to you condition, and we are asking to do something here. I'm not writing completely, I'm just making you understand. Here, else if score greater than equals to 80. Let us say I'm writing something here, right? So when I write code in such manner, what happens? The complexity of a your program gets increased. Okay, so the complexity, the higher complexity indicates you will be having a more branching. Okay, when you have a more branching, okay, when you have a more branching, it is very hard to maintain a code, and this kind of scenario is perfectly suitable for readability. Okay, next, maintainability. So when I say maintainability is a classic example is code duplication. Okay, when you have a code duplication, it obviously reduces the maintainability. Let us say there is a method called display, and it is trying to return hello, and I saw it is returning hello. Obviously it is a type of what, string function, string method, sorry, right? Then there's another method called message, and this method is also returning hello. This kind of duplication of a code reduces maintainability, and obviously it increases the maintenance effort. Okay, so when we have a repeated code, try to make it as a single code use everywhere. Okay, that's the best thing we can do. Next, efficiency. Fine. So what is this efficiency? When we write a code, okay, write in such a way that, let us say, there is a function int add a comma int b. Okay. So what it is doing, it is trying to return a plus b. If you see this code, it's very simple. Like we are taking two parameters into a function and it is simply returning a plus b. Okay, the more you give precise instruction, it will be better and the method will be works very efficiently. Okay, so these are the reasons you need to keep in your mind. So what is the reliability? Let us say in your code you have written or you have declared a variable, you have not used that variable anywhere. Okay, so it causes reliability issues. Okay, when you have a unused variable in a program, please try to don't write those things. Okay, somewhere if you see it, if you're not able to use that variable after declaring it, once you finish the code, please try to eliminate that code, that variable from your program. Okay, so that we can clearly avoid this reliability issue. Now obviously security, we already know security. Always remember, whenever we store a password, okay, anything related to encrypted data, okay, don't hard code the value. Okay, either you try to get it from database or you try to use encryption methods to get the password. Okay, so if you see here, I write like this: string password equals to hello 12345 at the rate. So this is not a best practice. Okay, if you see, maintaining a best practice is nothing but a code quality. Simple term. You maintain a best practice to write a code, obviously it will promote you the code quality. Fine. So if you see, if I go above, okay, we are talking about Java and we are talking about SonarQube. So what I'll do is I'm using STS. You can see here. Okay. Already I created some basic sample project. Okay. So that I'll analyze and I'll show you how the code will affect our deployment. Okay. So first thing is you need to install, to do a static code analysis, you need to install SonarQube in your system. So right now we are going to run SonarQube locally. In next video we'll talk how to do it Sonar in cloud. Okay, and we also talk about Sonar Lint also. Okay, so as of now we are restricting lecture for today is what? SonarQube. So SonarQube, first thing you need to get it from the Google. Okay, I will show you how to install it in your local and how to set up in your local. Fine. So before going into that, we do have certain matrices in the code. You know, when I say code quality, it's very important to maintain certain code metrics. Okay, first code metric is cyclomatic complexity. So cyclomatic complexity is nothing but what I already said right at the beginning. The more branches you have, okay, so the more problem you will get, the more complex the program becomes. So that thing is called what? Cyclomatic complexity. So what is the first metric? So you need to maintain this thing. What is that? Cyclomatic complexity. Okay. So what it will do, it will measure the complexity of a program. Fine. To control the flow graph. So higher complexity indicates you having the more branching potentially hard to maintain a code. Clear? So the more branches if you are having, it's nothing but what the cyclomatic complexity is higher. So it becomes very harder to maintain a code. So we try to reduce cyclomatic complexity so that our code will intact, means to the code quality. Fine. Second matrix is we already discussed code duplication. Code duplication. Fine. And third matrix is test coverage, and this is another beautiful lecture we are going to see. The third video. Second, I'll cover sonar lint. Next video. The third video will talk about test coverage. Fine. So we call it as code coverage, right? So next, the static analysis. Just now I said. So static analysis is nothing but what? Pardon me. Okay. So what is that? It will identifies the code smells. We'll see what is this code smell. Fine. It will identify the bugs and it will identify the vulnerabilities. Okay. So most of the vulnerabilities is what we talk about security only, that we will see in short. Okay. This is static analysis. Fine. So these are the four different matrices we need to keep in our mind, and that how we are going to encounter. Okay. We will see through via sonar cube. Remember, SonarQube tool is used for the static code analysis. Fine, right. So before writing any Java code, okay, you can have a SonarLint uh, in a local, or maybe you can integrate SonarLint to your Eclipse ID or STS ID, whatever ID you are using it, even maybe IntelliJ. Now, another is you can do is install SonarQube in your local. Okay, try to run the SonarQube server. Fine. Then you just bridge the SonarQube server to your code so that it will do certain analysis. Okay. Now what we are going to do, the first thing SonarLint thing we are not going to see now. That focus will be we are doing in the second video. In the first video we are just focusing on the SonarQube, right? So first video we are just focusing on what? SonarQube. Let us go to the Google first. Let me just remove everything from here. Uh, okay. So first, between the code and everything, I will share the Google Drive link in the comments later part. But as of now, you just see the code means video. Okay, so what we can do now is, first point, you need to get your SonarQube, right? Download the SonarQube. And second, we will see how to set up the SonarQube. Okay, so then we'll try to write our Java code. Fine. I'll try to write our Java code. To write the Java code, obviously, remember we need to create a Maven project. Create a Maven project because in Maven we will have pom.xml, so it will help us to build the project very easily. So it becomes for us very too easy to analyze it. Okay. So before running only, when we trigger a build, the analysis will take place. Fine. Let us go to the STS. Okay. Before that, I'll show you the some basic steps how to uh, download your SonarQube and all those stuff. Okay. Just a bit. I'm checking for the browser to get open. So step one. Again, I'm writing. So install and set up SonarQube. So how to do that? Come here. Oh, not this one. Oh, I'm not able to. SonarQube. Okay. So go to the SonarQube. Fine. If you see, you can hear they mentioned in a diagram clearly. You see here reliability, maintainability, security review, coverage, and duplication. These are certain matrices. I'll just focus later. Okay. Then click on the start free trial it. Oh my god. Not getting it. SonarQube download. Okay. Go to the SonarQube download. If you see the community edition, click for download for free. Once you download it, it will generate a zip file. You extract that zip file. Okay. So let's show you. So just extract the zip file. So SonarQube. You can clearly see here. When you download it, you will get a zip file. You extract it. This is your SonarQube. And go to SonarQube. go to here, go to bin. Okay, it's Windows, right? Go to Windows, this thing, just click on start Sonar. Okay, clearly you can see here the path, SonarQube, bin, Windows. In that, just click the start Sonar. The local server will start automatically. So it will take some time. Okay, so before that, let us see the second step. So how to, so third step, prepare. We need to prepare our project now. So we need to see how to create this Maven project. So, okay, so what I do, I'm going to create one Maven project. Go to, please install Eclipse or STS in your system. Go to new. Okay, click on other, click on Maven, click on next. Okay, so just check the create simple project. It will have the certain already skeleton. Okay, the default skeleton we are going to use it. Click on next. See, you can give the project name here. Okay, so when I write here, here I'm giving a package name, group ID, home dot, some example. Excuse me. Sorry, sorry. Okay, so here you can write sample demo. So write the sample demo project. You don't do anything, you just click on finish. If you see at the bottom, it is creating the Maven project. Okay, you can see clearly sample demo. Go to the form.xml, right? You need to change this to above 1.7. Okay, that we will see how to do that later. So form.xml, you see here, this is the thing. If you want to install any jar dependencies, you can directly copy paste the dependency. When you build it, automatically it will add the jars into your program. So that is the advantage of your Maven project when you're having the form.xml. Fine. So remember, I've already created one project. So I'll just take pom.xml from that. Okay. So whenever you wanted to integrate SonarQube into your project, what you need to do is you need to do few things. One is what you need to add the properties. Okay. If you see here, my SonarQube is operational. It is showing means now we need to go to our localhost. SonarQube defaultly runs on 9000 port. When you click this, excuse me, when you click this, you will get this particular thing. Okay, login and password. The login and password when you're logging for the first time, remember both is admin only. Admin. Okay, when you log in it, again remember when you're logging it for first time. Okay, so you need to give admin and admin. Okay, then it will prompt for to change your password. Now I've changed my password to admin at the rate 123. Okay, just log in it. Okay, once you log in it, it will show you the interface like this. Okay, don't look at this. Okay, I'll tell you what exactly it is later. Just go to the rules in SonarQube. Okay, go to the rules. So you can see for Java, there are 632 rules are defined. When I click on this, okay, let us check one rule called maintainability. Are you able to see here maintainability? So when I click this, what is the rule they are telling? At the rate check for null or nullable should not be used on primitive types. So whenever you are using this primitive data types, for that primitive data type, you should not use the annotation called check for null or nullable. Now, why this issue are getting it? So they clearly give the definition. By definition, primitive data are not objects, so they cannot be null, obviously, right? So if you are adding this check null or nullable on primitive types, that unnecessarily create a confusion, which is useless. Okay, so this rule raises an issue when you are trying to set on a method which is returning of a type of primitive types. If you see, most of us will try to write code like this. If you write this like this, it will generate, after the code analysis, it will generate a issue called non-compliant code. It is first thing, and it will generate the issue called maintainability. Okay, it is a low impact, but still. So what is the solution? The solution is that you need to remove that particular thing. So what is the beauty of this SonarQube is when we write a code, when we are analyzing it, when we are deploying a project into SonarQube, it will analyze it, it will give our code smells, and it will give the solution. So according to that, we need to fix our code smells. That is the advantage of this static code analysis. Clear? So if you go above, scroll above now, let us see in other issues also, if we can see anywhere. Uh, See, we'll see a reliability. Reliability issue is nothing but a bug here. Okay, before we have seen it is a code smell. This is what bug. If you see that, now what is this? Dot equals should not be used to test the values. So you should not use this dot equals. So when you want to test the value, you should not use it of atomic classes. So why it is? Again, why the issue? How can you fix it? Okay, so the equals method in atomic integer and atomic long returns true. Only two instances are identical, not if they represent the same number of value, right? So this because equals is not a part of your API contract of these classes, so obviously they do not override anything here. Okay, so if you see here, only the API contract of implementing classes like integer, long, float, that provides the assertions. So you cannot use this particular thing. Okay, this particular dot equals. to test a value for the atomic classes. If you do so, it will create a bug. So obviously it reduces the code quality. Okay, we do have certain ratings for code quality and we will see how we are going to achieve it. Fine. So this is how once the SonarQube is running, it will display the login page. If you are logging it for first time, you give admin and admin as your username and password. Okay. So once you log in it, it will give you password change opportunity. You change it, right? So go to the projects again, keep aside. Let us focus on our STS now. Now, what is this? So if you want to use this SonarQube in your project, you need to add the Sonar properties. So what are the Sonar properties I can use here? First, the server URL. Obviously, we are running this Sonar host URL in our local host. Okay. Second, our project name. Okay. Sample project. Right. Third is what? Sorry, project key. Just now we have given some artifact ID, right? That's one. And the project name. Okay. And the SonarQube version. And we need to give the login and password also. So I'm just already have created this. So same thing I'm copy pasting in our this thing. So is instead of sample project, it should be sample demo. Okay, and it is the project name is what? Sample demo only. Right, and we know this admin and admin at the rate of 123. So remember, these are the properties you need to add. So this pom.xml, anyhow, this code, everything I'll be putting in a GitHub. Okay, I'll just share that GitHub link into the our comment section. From that, you can get it. Okay, or else I'll just add this pom.xml properties in the comment section. Clear? So this is how it works. Fine. Next thing, when we build it, right, we need to send the analysis to our SonarQube. So to do that, we need to have okay this particular Maven plug. Okay, so if you do that, just copy this build and just paste here. So we are adding the all different jars which are required for project. Right. Once you add this, let us create some classes. So what I do, I already created one class here. Not class. I'll just take one more class like circle. Okay, from the other project. Let us say in sample project, we are creating this. This is my class. Okay, so circle, right? Circle 2 we will give because it is the same project maybe. So sample project, not sample project, ours is sample demo, right? Sorry for that. Okay, so circle, I'm using only default package. Okay, no need to worry about it. Just circle. Okay, let us see that's created. I just copied from there the code I'm pasting here. Now this sample demo consists of only one class. Now what do we need to do? We need to do some build configuration for this. Right click on this project. Okay, you do Maven build. Oh, Maven. Oh, sorry. run as Maven build. So when I click on Maven build, okay, so it will ask for your configuration. Okay, it will ask for us to set a configuration. Here we need to set up a goal. Okay, if I show you run configurations, I've already created one run configuration. Okay, so the goal is what? Sonar. Okay, what we need to do? We need to write what? Sonar. In the goal, what we need to write? Sonar colon sonar. Remember again, go to your project. Once you create a class, once you create a form.xml, okay, you try to build your project. Okay, I'm doing Maven build. When I do Maven build, it will ask for me to give me goal. But I'm giving the goal. Goal is what? Sonar colon sonar. Just click on apply, click on run. Okay, let us see the console what it is throwing. If the build get is success, our project will display in the our sonar server. Just just wait for the build thing. It is taking certain time. So the build is success, and go to our SonarQube thing. Just you refresh this. Can you see the sample demo? Okay, click on that project. It will show you the overview. Okay, the issues. No issues as of now. Okay, still the analysis is going on. If you see here, still the analysis is going on. Just we'll wait once it is done. See what it is showing. The quality gate is passed, means we deployed our this application like successfully. Okay, it is showing that your quality gate is passed. Means that you don't have, eventually you don't have any bugs, nothing but reliability. You don't have any code smells. We have one code smell. What is that? We'll check now. Okay, one maintainability. So one security review we have. Can you see here? Okay, and we have this particular thing called vulnerability called security. We don't have anything, and we have certain code. Okay, there's no duplications in our code, and this code coverage we'll discuss in third lecture. So how to write the unit test case and all those stuff. So as of now, we are just worried about this thing. When you go to the overall code, so we didn't add any new code, right? So overall code and new code will be the same as it is. So we didn't have any new code here. Okay, overall code. So go to the issues now. Okay, when you go to the issue, we didn't create any package, right? I already said. Okay, we directly created a class. We have, so what it is showing, it's a adaptability issue, right? It's not a good practice. Even though it is a low impact, can you see? Even though issue is a low impact, but still it is an issue. If you see the code smell, now what is saying, issue types are deprecated and no longer can be modified. Okay, Let us go to the code. When I go to the code, okay, it will show me the form.xml and this main Java. In circle, if I click on this circle.java, obviously it is showing one code smell here. Okay, there is a symbol, show the code smell. You click on the code smell, then move this file, okay, to named package. Now, why this issue is coming? That we need to check. Okay, click on that. So now you will give his explanation. Java packages serves two purposes. Okay, right? One is structure. Another is what? Avoiding name clashes. Okay, so to do that, so if you're not doing this, that is an issue if you don't declare a package. So the how to fix it, even the fixing also is given. What is the fix? Move your class to package directory, or you write some particular package name. So this is my non-compliant code. Can you see here? Means I have not declared any package above my class. So this is an issue. Now what is saying the solution also you mentioned. You declare some package. Now automatically your code becomes what? Compliant. I hope you are able to understand what we are trying to do here. So when we write any Java code, the analysis is must. So before deploying this application, okay, into the cloud, in the sense before making an application runnable, okay, we need to check the quality gate, sonar quality gate. If the sonar quality gate gets failed, obviously our application will not get deployed. Okay, so if you see the overview again, now the quality gate is passed because everything looks fine now. Okay, let us do one thing for our understanding purpose. I've already created one more class. I've already created another uh, project. Okay, uh, give me a second. Just removing all these things. Let me just expand this code base. Okay, I hope you are able to see the code. So I'm going to create code smell bugs demo class. Uh, in my sample demo. I already am using the code which is already present in other project. The class name code smell add bugs demo. Okay, just finish it. I'm just copy pasting it now. This particular code. Just copy this and I'm pasting over here. Right. So I copy pasted this. Let us see. Again, we need to build our project. Okay, and check. And there's a error. What is the error? If you see here, I already said. So you need to make the project compliance to 1.7. It is 1.5, right? So it is already giving a suggestion. I'm just changing it to that. Okay, the error is gone. Now let us say, let us build this project. So how to build it? Just now we have seen run as. So we already have this run configuration, right? And what I do, we already run that. Just click on this. The two things are there. One is sample demo, this one. I'll run this again. We need to build it again, right? When we add it, we need to send this is to the analysis purpose. That's why we are building it. Let us see if the build gets success. Remember, If you need to have a code quality analysis, so we need to create a Maven project. So because it helps us to build a project. Okay, the build is success, right? Let us go to our once again to the server. Let us refresh our code. See here, still the analysis is going on. Okay, let us wait. It is done. So the analysis is done. Let us refresh. See, the code quality is failed. Code quality gate is failed. Now, drastically, our code rating is done. So the rating is given is B rating. Okay, so we should have a rating, good rating to our project. Then only it can. This code coverage we will see. This 80% we need to have how to write this code coverage and all. Later we will check. But there are 21 new issues. See, in the new code, in the overall code, it is already 23. It is showing whatever the new code we added. So there is an issue. Okay, so what are those issues? Okay, let us go to our code again. We'll check one by one. We already know we don't have any issue here. Let's go back here. See here, many bugs, many bugs. Can you see here? Almost 22 code smells we have in this code. So these are all things we need to fix. Okay, the first thing, this we already seen when we don't have a package, it will give us code smell. Uh, okay, if you click on this code smell, now what it is showing, remove this unused variable. Okay, this is unused. Now why when it is again a maintainability issue, now why this is issue again? So when you click on this, so maintainability, what it says, if if give me a second, if a private field declared but not used locally, if you are declaring a variable as a private, if you are not using it, then its limited visibility makes it as a dead code. Okay, this is either a sign that logic is missing or that code should be cleaned. Okay, so because of this thing, it's an issue. Cleaning code, cleaning out dead code decreases the size of maintained code base and making it easier to understand and preventing a bug sign from introduced. Then what I need to do? Uh, so what I can do for this, like in order to do this thing. So when you this is a non-compliance code. That non-compliant code will come compliance when you remove that variable. That's it. That as simple as that. Okay, just you remove that unused private variable. Fine. So this is another issue. There are complete multiple issues we can see here. There is an issue for system.out.println. This is very common issue we will get when we deploy our project. Okay, what is that thing? We should not use this system.out. We supposed to use logger only. Again, why this issue? Okay, why this issue? The see if you see here, in software development, logs serve as a record, okay, of events written in an application. So providing crucial insights for debugging. When logging, it is essential to have a logs. Okay, so easily accessible. because of secure. So if you see this, following is a non-compliance code is writing system.out.println. Now this system.out.println, I can make it as like this. Logger equal to logger dot get logger. Okay, get class dot get name. Okay, so this I'm making it as a logger dot info. What I do, I'll just copy this code from here. Let us make this issue as a, we'll remove this issue. Okay, fine. Copy this, go to your code. Logger is not there, so we need to import it. Right. So wherever system is there, see the code, what is said in non-compliant side. Once it is done, oh, so logger.info, right? So go to the code, wherever system.out is there, we'll make it as a logger.info. Just copy this, Control F, find, right, logger.info, replace everywhere. Select all, you can see, wherever it is there, replace all. Okay, just is there is an error somewhere. So here it is not possible. So uh, we'll make comment as of now. We'll see later. Okay. If you see, again I need to build this project. Go here, build the project. See that your build it get success. Oh, it is taking time, and so the build is success here, right? So let us go to the this particular thing. Just refresh. Just close this. And close this also. Just go to the overview. Okay, before it was 22 some code smells, it is registered to 14. You can see the overall code. Code smells is 15. You can go there, the code, open this, open this. You can see any, we don't have any issue with the logger info. See here. So we made our code as a complacent. Like that, we have many code smells. Okay. This is how we are going to do the static analysis, and this is how we are going to solve it. Fine. I hope you understood. So what's the task for you is, so you check every issue. Okay, click on Java and check every issue. What are the different issues are there? Why we are getting it? How we are going to change our this kind of code and all? We need to check it. Okay. So what we did till now is simply analyzed our code. So if you don't maintain a code quality, okay, so it will reduce reliability, maintainability, and we have certain security reviews also. So what is that? I will show you now, right? So there is this one security review. I think it should be in a pom.xml. Give me a second. I just will go to the code. If you go to the pom.xml, there is an issue. Oh, this should not be given in a hard coded manner. It's supposed to show the vulnerability. Give me a second. Security hotspots. So we'll get it. We should get that. Okay. Can you see? Admin. We just hard coded it. We should not do that. Okay. And then what we need to do? Okay. Where and what's the risk? How can I fix it? Okay. Store the credentials in a file. Okay. Or store the credential in a database. Like that you can do that directly. Don't hard code the value. This is an issue. One more issue. Okay. If you go to the overall gate, if you see here, uh, you have A, rating A, right? Rating. When I give E means totally uh, it's less than 30. When you get a code rating E means what? You have a less code quality. Okay. So A, B, C, D, like this, we have the ratings for the coding also. Okay. So this is all about SonarQube. Again, I'll just revise what we discussed today. The first point is what? Code quality is a very essential when we write any coding, and it tells us how our code is written, how well formed it is. Okay, if you're not able to follow the code quality, we have certain issues like reliability, maintainability, security, okay, vulnerability. So these issues will pop up. Okay, so before deploying in code into the deploying and running the application, so what we are going to do is we are going to check whether whether our code is passing the quality gate or not. If it is passing, then only your application gets deployed, otherwise no. Okay, so you need to follow the code quality. I hope you have you liked my lecture. Okay, and stay tuned for another videos. Okay, in the next class, I'll talk about Sonar Lint. On that time, we need not to have any Sonar Cube and all. Go to the marketplace, just install the Sonar Lint. Whenever you have this, you can directly right click on this. Whenever you are writing a code, automatically it will show the code smells in the code itself. Okay, when you plug the Sonar Lint to in your Spring tool. Okay, nothing you'll be seeing in the next class as of today. So we discussed what? Code quality. Okay, if you like my lecture, please subscribe to my YouTube channel and like the video. Please share the video, okay, to the larger audience, so it will benefit for the more student community. Okay, thank you and thanks a lot. Bye.